for the review, we're going to go through this here. So we have two functions, f of x and g of x, and we want to find f minus g of x. So that's taking all of f of x, 4x cubed minus 5x squared plus 8, and subtracting, or taking the opposite of g of x. So the opposite of 2x cubed is negative 2x cubed. The opposite of negative 9x squared, which becomes a positive 9x squared. And opposite of negative 7x is a positive 7x. So you got to make sure you distribute that negative to all of the equation that follows. Now just combine like terms, cubed, cubed. So we got 2x cubed, x squared, so we got 4x squared, and 8 and 7, that's a 7x, that's an 8, so those, I can't combine those. So I just lead with the positive 7x and then a positive 8. And I look for that answer in here. It looks like, what? This one down here, all positives, that one. Okay, then given this function and given this function, divide them. Okay, so then you just take the top and divide it by the bottom. So there we can do synthetic division because we have a degree of 1, right? And there's no lead coefficient here. So we can just list our coefficients. 2 is a cubed, 3 is a squared, negative 7 is 1, and then we have our constant, right? And then we set this equal to 0, so x equals 2, right? So we plug that in. You got 0 in this first one, 2, 4, 11, 22, 15, 30, we get 0, right? So then our answer, when we divide this, is 2x squared, because we have cubed divided by, to the first is squared, and then plus 11x, and then plus our constant, right? So that's our answer to that division problem, right? And where our domain, if it asks for the domain, our domain can be everything but 2, right? Because if we plug in 2, we divide by 0. Okay, so our domain is x cannot be positive 2, but it can be everything else. So that's how we would divide them. So only if you have a degree of 1 and no lead coefficient, then actually synthetic divide it. If not, you can write it like this and then set what your domain is. Okay, but if it's a linear term right here with coefficient of 1, then go ahead and do synthetic division. Okay, number 3, we want to find what is, looks like f of g of x and then g of f of x, and which one is neither, okay? So we're going to look at f of g of x would be taking g and plugging it into f, right? So let's take negative 1 and plug that into g, okay? So negative 1 into g, well, that doesn't have a negative 1 to start, right? So it's not this one. This one says take f and plug that into g. Okay, so we're going to take this f, we're going to take this x, negative 1, and plug it into f. So f, negative 1, we're going to plug it in, and we get 8. And I want to take that 8 and plug it into g. So I'll take that 8 and plug it into g, and I get negative 2. Is that what I get here? Negative 2? Yes. So it is g of f of x. Okay, now I do this one. I take 5 and I plug it into g first, right here. So if I plug in 5, I can get out a negative 1. And now take that negative 1 and plug it into f. Negative 1, I get 8. So I should get 8, not negative 5. So it's not this one. Okay. Now I can do f of g. So take 5 and plug that into f. So I'll plug that into f, which I do get something out, right? F. There's my x. I get a negative 2 out. And then I want to take that negative 2 and plug it into g. Negative 2, negative 2, negative 2, no negative 2. So it's not that one either. So that means it's neither. Okay, negative 4, I'm going to plug it into g. I do have a negative 4 right here, and I get a 7 out. Now I want to take that 7 and plug it into f, right? Is there a 7 there? Yep, I get 5. Oh, and I do get 5, so that's this one. Okay. Then I'm going to plug in 2. I'm going to plug 2 into g. Can I plug 2 in? Yep, I get negative 5 out here. So I get plug in 2, I get -5. Now let's take -5 and plug that into f. -5, -5, no -5, so it's not this one. Okay, now we're going to try f, or g of f of x. So I'm going to plug in 2 into f. So there's 2. I get -4 out. Now I'm going to take -4 and plug it in g. -4, -4, and I get a 7 out. Do I get a 7? That is a 7, so it's this one. So that's how that's kind of played out. You take the x that you're given, and you plug it into the inside one, and whatever y you get out, you plug that into the outside one for x, and see what's the answer you get. And if it matches with those, then that's the type. All right, next one, what is the domain and range of f of g of x? So inside out, g into f. So I'm going to take g, substitution into this x. So instead of 3 times x, it's 3 times something. Then I subtract 7. Well, that something is this equation, 4x plus 5. 4x plus 5. And now I just simplify. I get 12x plus 15, and then minus 7 is 12x what, plus 8. And because this is linear, right, linear equation, I can plug in any number. So my domain and my range is all real numbers. Basically, anytime it's an odd, right, an odd polynomial, an x to the first, an x cubed, that's going to be all real numbers and all real numbers. All real numbers. All real numbers. Okay, so that's it for 1 through 4. Okay, number 5 here, we got this parallelogram, A, B, C, D. Those are just points, and it wants us to graph the inverse of point C. So point C, go over 6, go up 8. So C, point C is 6, 8. So the inverse of that is just switching the x and y. So C inverse would be 8, 6. So I just go over 8, go up 6. There it is, C inverse. That -1 up there is not an exponent, it is word inverse. Okay, and then on this one, number 6, we're matching the function to its inverse. So we're just going to draw lines which function equals what, or the inverse, right? So here, if we have this equation right here, then the inverse of that, I switch f of x to y. Then I'm going to switch my x's and y's. And then I'm going to solve for y. Divide by 2. So I could divide this by 2 and this by 2, or I could divide the whole thing by 2. I'm going to put it this way because then the last step is to write this as f inverse of x equals 1/2 x, right? 1/2 x minus 3/2. And then I can graph, which would be, I would go down 1.5. So I should go down 1.5. 1.5, and then I should use my slope, rise over run, so up 1 over 2. So it probably looks something like that. And then I can look for that graph. So I should be down 1.5. That's 1, that's 2, so not that one. That's 1, that's 2, not that one. That one's 0, so it must be on the next page here. Got a couple more, that's 2 more. There we go, 1.5, and then up 1 over 2, boom, right there. Okay, so this is y equals 2x, what was that, plus 3, I think. Okay, yep. Okay, now the next one, this one, I'm going to switch my f of x to y. I'm going to switch x and y. I'm going to solve for y, so subtract 2 on both sides, and then divide by 3, and then switch it to f inverse. Right, so it's 1/3 and down -2/3. So down -2/3. Down -2/3. Let's be on the next page. Down -2/3. Down maybe one more page. Down -2/3, probably this one, and then rise over run, it's 1 up 1 over 3. So 1 up 1, 1, 2, maybe that one. So yeah, it's this one, y equals 3x plus 2. That's the inverse of it. Okay, because you go down 2/3 and then up 1 would be like right here, and then over 1, 2, 3, right there. Perfect. Okay, do the other one. Go back. Okay, switch colors here. So this one, change y from f of x, switch x and y, solve for y, so it's just x minus 4 equals f inverse of x, right? Last step is to switch this y to f inverse of x. So x minus 4, so that means we're down 4, so let's look for one that we're down 4, down 2, down 0, 1, 2, 3, 4, so it's probably this one. And then we have a rise over 1 is just 1, up 1 over 1, so it is this one. So this is y equals, what is it, x plus 4? Yep. All right, now the next one, switch colors, last one. Switch that to y equals 4x, switch the x and y. So that'd be y divided by 4, so just 1/4, so 0. You're not adding or anything, subtract anything, so it should be at the origin 0, so let's look for that at the origin. So this one's at the origin, but then what's our rise over run is 1/4, so we rise 1, go over 4, 1, 2, 3, 4, so it is this one. Y equals 4x. That's the inverse. This is the inverse graph. Okay, so that's it for that one. So we matched them all up. Okay, now we got some more. We got some simplifying we want to do. We have mammals that can be modeled by using this expression. Which one is it written as a root, right? So 4/5, the denominator is your index, and your numerator is your power, but the only thing being raised to a fraction is the x, so that's the only thing going to go in the radical. You can put that right there, and then the 170 is not, so the 170 stays out. It's not being raised to a fraction, so that should be our answer, and we see that on this first one there. Okay, next one, fill in the blanks, rewrite this one. So it might be want the simplest form here. So the 8th root of 256, and then I'm going to raise that to the 3rd. So 256, I believe that is 2, and then 2 cubed is 8. So I believe this answer should be 8. 100,000 to the 5th, or 1/5 would be a 5th root, but it's to the -2, so I'm going to raise this to the -2. So 100,000, what would that be? So 1, 2, 3, 4, 5 zeros, so that'd be 10. And 10 to the -2, the negative just flips the base, and now it's a positive, and 10 squared, and 1 squared is 1 over 100. So this is 1 over 100. Okay. So I guess 1 over 100 is, just move the decimal over twice, right? So it's this one, 0.01. All right, this one's asking you to use rules of exponents, right? We add exponents. When we multiply, we add exponents. Multiply by the same base, we add exponents. So what is 2/3 plus a -1/4? Well, a common denominator, right, would be 8 over 12 plus -3 over 12, which is 5 over 12, would be my exponent, right? And this, what is a and b equal? That's just saying what this fraction is. A is the numerator, so 5 would that be that one, and then b is the denominator, that would be 12. All right, moving on through. Graphing these, you know how to type it in your calculator, you could try that. But really all we have to do is look at this, it's negative, so we know it should normally, square root, right, when you see square root, it should look like this, right? So because of that negative, we know it's going to face down. And then this +6 in here, we know it's going to go the opposite, so it's going to go left 6, 1, 2, 3, 4, 5, 6, and face down like that. And then this -2 out here is just going to drop it down to 1, 2. So it should in the end be something that looks like this. Over 6 and down 2. Over 6 and down 2. Boom, probably right there. That one's not even close. Look at the last one here. Nope. Right, so it's going to be this one right here. All right. All right, so we got this dodecagon, three-dimensional shape, 12 regular pentagon faces, and it says if we want to find the approximate length of the edge right around it, we could use this formula right here. So all they're doing is just asking for what is the domain and range of this function, right? So it's raised to the 1/3, so this whole thing's being raised to 1/3. So that's what's going to be in the root, right? And it's a 1/3, so it's a cubic, right? So what can I put in for this number? Can I put any number in here? Right? Can I take the cube root of anything, right? Which I can. I can take negative or positive, so all real numbers. Real, spell real correctly, real numbers. And then what am I going to get out, right? As long as I put in anything in here, I should get all real numbers out as well. Right, so look at what that denominator is, and that will help you. If it's an even, that means we can't have negatives, right? But if it's an odd, that means we can have all real numbers out. Okay, so I think that's it for this page. Yep. All right, this function, which function represents this? So what does this look like? Now, square roots look like this, and cube roots look like that, right? So all even roots kind of look like this. All, not like that. That's bad. More like this, right? All cube roots kind of look like that. So this looks like a cube root, right? Or fifth root. So we all have this in here. So notice all thirds, 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 those are all cube roots, right? But how does it move? So we notice it moves down 1, 2, 3, 4. So we know we should be subtracting 4 after we take the cube root. Now you could plug in numbers, or you could graph these and see which one matches up if you want to do that. But we know it's going to move down 4. And you remember on the inside, if we rewrite this, this would be x plus 4 cube root of that. This would be x minus 4, the cube root of that. This one would be the cube root of x and then plus 4, and this one's the cube root of x minus 4. So we can see that it's this one because the outside just moves it down, right? Okay, how do we add? Well, to add, we have to have the same exact radical, same index and same number underneath. These are not the same, so we can add them, but maybe we can break them down to be the same, right? So square root of 12 turns into 2 root 2 root 3, sorry. But this 7's already on that side, so 2 times 7 would be 14 root 3. Break 48 down, 16 goes into it, so this would be 4 root 3. And then the 2's already on the side, so 2 times 4 is 8. So notice how those both have root 3's in them, so then we can add them. And then 75 breaks down by 25, 5 root 3, but that negative 4 is on the outside. So negative 4 times 5 is a negative 20, so 20 root 3. So even though we couldn't from the beginning, but since we broke them down, now they all have root 3's. Now we can add and subtract them, right? So 14 plus 8 is what, 22? 22 minus 20 is 2, so this is 2 root 3 is our answer. Okay, looking at this, the length is this units, the width is this unit. So take our width, or length, and our width, and we want to express the area, so we're just going to multiply those. So I can take the outside times outside, so 3 times 2 is 6, right? So we're good there. They're both fourth roots, so we can multiply the inside. But instead of multiplying 162 by 40, I might as well try to break it down and look for groups of 4, right? Since it's a fourth root, this would be 4 times 10, which is, I'm going to expand this a little more. We know 2 times 3 is 6, so we'll do that. This is 2 and 2. This is 2 and 5. This would be 81 and 2. So it looks like we have a group of 4 of 2. So we can pull a 2 out with that 6. What about breaking down 81? That would be 9 and 9, 3 and 3 and 3 and 3. So a group of 4, so pull another 3 out. So we have this lonely 5 left. So that's going to stay in the fourth root, right? And then we can just look at our variables now. We got x to the 4, so that means we got 4 x's, so we can take an x out, right? This one we got y to the 7th, so how many times does 4 go into that evenly? Well, that goes in evenly once, so we can take 1 y, but we have three y's left over. And so, but then we have 5 right here, so 3 plus 5 is 8, so we really have y to the 8th. And how many groups of 4 do we have in 8? 2, right? So we can take 2 more y's out. Okay, and then we have an x cubed left. Well, there's 3 of them, right? So we can't get to 4. So that x cubed has to stay in there with this 5. So we have 2 times 6 is 12. 12 times 3 is 36. So we have 36. We have 1x, and we have y and y squared, which is y cubed. Fourth root, the 5 has to stay in there. and then the x cubed has to stay in there. So that is our final answer, and as we can see, that is right here, right there. Okay, so make sure when you multiply the inside times inside, but if you can break them down first, right, if you want to, and then outside times outside. But as long as they have the same root, that's when you can multiply roots. Okay, this one, rationalized denominator, remember, we look at the type of root, it's a cube root, so that means we need 3 on bottom. So I need 3 8s, right? So add 2 more, now I got 3, so I can take out 8 at the bottom, right? And then on top, I have to do the same thing, 2 more 8s, and this is not inside the root, right? So you can't multiply these. So I got to take 7x to the 4th, y to the 5th, stays on the outside, and then 8 times 8 is 64, so cube root of 64. And then we can maybe, let's see. Oh, I guess they weren't asking that. They were asking if we can just multiply the numerator and denominator by cube root of 8. But because it's a cube root, we need 3 8s, right? So it would just have to be the cube root of actually 64. So this is false. But you could break it down like that, and that's how it's simplified, right? You could even break the 64 down to 8 and 8, right? We already know. And then 2, 2, 2, 2. So really I could take out a 2. So I could really take out a 2. So if I pulled out that 2, it'd be like 7x to the 4th, y to the 3rd, y to the 5th, y to the 5th. And a 2 as well, right? And then this lonely 2 would stay in there. But then I could break down that 2 and cancel with this 4 and like that. So that's how it's simplified, right? So which means that really this cube root of 8, isn't that just 2 times 2 times 2? So really, can I take out a 2? So to rationalize the denominator, I could really just don't even have to multiply by anything. I just factor out a 2. Right? 2 would come out of there. So this is false. But even if you're asked to rationalize it, you need 3 8s total, not just 1 8. All right, let's see here. Select solutions, right? So we're just solving for x. So we got to get the radical by itself, which it is, and then we can square root both sides. So we square root both sides. But when I square root these two things, I got to FOIL it out, right? X times x is x squared. X times 1 is a negative 1x. Negative 1 times x is another negative 1x. So I got x squared minus 2x. And then negative 1 times negative 1 is a positive 1. And that now I can get rid of the radical, right? Cancels out, so I just get 3x plus 7. And now I can just set it equal to 0, so I subtract 7 and subtract 3x. So I have 0 equals an x squared minus 5x minus 6. Now I can cap this or use quadratic formula. What times what is negative 6 but adds to negative 5? Well, that would be a negative 6 and a positive 1, right? And then divided by my a, which is 1, so that's not going to change it. So here are my factors. And then I can set those factors equal to 0, so I get x equals 6 and x equals negative 1. Now I want to plug those back in because maybe I can't take the square root of a negative, right? So if I plug in 6, I'm going to get a positive because those are all positive. If I plug in a negative 1, I get negative 3 plus 7, which is still positive. So that does work out. So let me check all the way though. Okay, so we have these two. We have 6 and we have negative 1. So it could be this or this one, right? So we need to check our answers to make sure. So if we plug in 6, we get 18. 18 plus 7 is 25. Square root of 25 is 5. If I plug in 6 here, 6 minus 1 is 5. So 6 does work. But let's see if negative 1 works. Okay. So if I plug in negative 1, I get negative 3. Negative 3 plus 7 is 4. Square root of 4 is 2. And negative 1 minus 1 is negative 2. So I'm pretty sure they're probably going to say, it's probably going to say just 6 is the answer. Because they're probably looking at the principal square root, I would say. So it's probably just going to be 6. Okay. This one solving, we need to get the raised to the 1/4 by itself first. So we need to subtract 3, so we get 6 here. divide by 3 on both sides, so we get 2, so we get 6x. Okay, so we have 6x negative minus 8 to the 1/4 equals 2. And then we want to raise it to the 4th power, or the 4th root, right? And I don't know what the 4th root of 2 is, but we can use calculator. So that gets us to 6x minus 8 equals the 4th root of 2. And then we can add 8 to that, so we add 8 to that, and then we can divide by 6. So I just need to put this in my calculator. 4th root of 2 plus 8, then divided by 6 is my x. So if I put that in my calculator, I get like 1.53. 1.53. Okay, fill in the blank of these next ones. We got this equation, 1.23 root a, and so a is our altitude, right? So if we want altitude of 30,000 feet, I'm just plugging this into my calculator, 1.23 square root of 30,000. So I'm just basically just plugging that into my calculator, 1.23, push the square root button, and then 30,000, 1, 2, 3, and I get 23, 213. So we get 213. Same thing here. I want 300 miles. The pilot can see 300 miles above the horizon. And the plane must be at so many feet above sea level. So it's kind of going backwards, right? So this is an equation for miles. So miles equals 1.23 root a, and a is for altitude. So this one we're actually solving for a. So solving this for a, we just got to get a by itself, right? So we need to get this root by itself first. So we divide by 1.23, divide by 1.23, and then so we have whatever miles we're given. If we divide that by 1.23, and then we have square root of a. So get rid of square root by squaring. So if we take our miles, we divide that by 1.23, and then we square that answer, we're going to get what a is. So they want our miles at 300, right? So we're going to plug in 300 in here. So we're going to erase this miles. We're going to plug in 300. So we're going to take, on our calculators, we're going to take 300. So if you want to, you could do alpha link. So, or parenthesis, maybe first parenthesis, alpha link 300 over 1.23, outside parentheses, then square it. So you got to put the parentheses first and then square it, and then equals 59,488. 59,000, so rounding it, we get 60,000. So 60,000 is the altitude. Okay. All right, so that is it for Chapter 4. If you're reviewing any of the other ones for the final, make sure you look through the previous reviews and look at those notes.